This is Design Safe Radio, where natural hazards researchers strive to make our society more resilient to everything nature throws at us.
Welcome to another episode of Design Safe Radio. I'm your host, Dan Zahner, and it's really my pleasure to have my good friend, Dr. Erica Fischer from Oregon State. It's good to see you, Erica.
Good to see you.
Every time we get together, it just puts a smile on my face because you just got such a great energy about you, and you're working on cool stuff. And it's just really, really wonderful to get to chat with you today. I wish we could do it in person, even though we're only an hour drive away. But you are a very busy person. So give us a short intro on all the things that you're up to these days.
So I'm an associate professor at Oregon State University, and I do a lot of fire research, both in-field investigations post wildfires, as well as laboratory work and numerical simulations.
Yeah, we've got a special wildfire background for you today. So those who are watching on YouTube, you'll see that this is actually from a rapid deployment. So you see some orange shirts in the background. That's probably Mike Grillio.
Probably.
For my left elbow there. So thanks to the Rapid for taking such great pictures and data. But you look at wildfires from a different perspective. Some people might be surprised to learn that there's engineers that do research on wildfires. So can you kind of tell us a little bit about the various ways that engineers study fire? Like, is there a difference between, wildfires out in the woods versus structural fires, or is there some overlap there? Like, how does this go?
Yeah, it's a great question. This research field has predominantly been dominated by people who work in forest ecology or like just forestry in general, looking at fire propagation through the wild land, as well as then the secondary effects on our ecosystems. So exactly what you're showing in your background. But what we've seen over and over again in the more recent years, and especially in the most recent days and months, is that these fires are encroaching on our communities. They are intruding into our communities, and we are ending up with what we call an urban conflagration, where we have structure-to-structure fire spread. It's impacting our civil infrastructure, our roads, our transportation infrastructure, as well as our homes, and a lot of our major civil infrastructure, like our schools or our hospitals, our water systems. And because we as civil engineers and those of us a part of the Nahiri network really understand the systematic constructs of our communities and the interdependencies of our infrastructure systems, we are really primed to be able to enter into this field of research, to be able to investigate the impacts just throughout all of the disaster phases, as well as kind of interact with the community during the adaptation phase and mitigation phases.
Yeah, it's really interesting to hear talk about kind of these community, lifelines and infrastructure, and all of those interdependent systems. I mean, that's really what the Nahiri network scientists and engineers, you guys do really well, is looking at all those details of systems in themselves, components within those systems, but especially those interface areas are really important to take that engineering approach of gathering data and doing numerical modeling and large scale physical testing, all those things that inform how we make a more resilient society to all these urban interface. I love the urban conflagration. That's a great term. It feels like
it's really fun to say too. Yeah. Yeah.
Urban conflagration coming to a city near you.
Hopefully not.
Hopefully not. Yeah, put that on the back, right?
Yeah, that's what we're here for. All right.
Yeah, exactly. Who should get like a band tour t-shirt and it says keeping this from a city near you on the back. Make that happen, Marty. Let's do it. So what are some of the research projects that you and your team have been up to over the years with this focus specifically on urban conflagration? I'm going to say it until I can actually pronounce it right.
Practice makes perfect. Yeah, it's really developed over time. So we I started doing research in this topic after the 2018 Camp Fire. So I have a background both in building fires, as well as in post-disaster earthquake reconnaissance. And so after the 2018 Camp Fire, I was really primed to lead a team into the field and do systematic data collection on schools and hospitals. And so it really depends after each fire, what is there to learn, just as we have been kind of going through that process for some of our other natural hazards. And so after the campfire, I was very interested in schools and hospitals, particularly because California has very stringent design guidelines for earthquakes for schools and hospitals. We thought it was very interesting that there was so much damage to those in the town of Paradise. And during that time, we were working with a social scientist, Sarah Hamadeh, out of Stony Brook University. And we were really able to kind of get in and interview school counselors and healthcare workers to understand not just about, okay, that this school was damaged or this school burnt down, but what were the social and economic consequences of this infrastructure damage?
Mm.
And for an engineer, this is really powerful because we can then be using that understanding to push forward mitigation, to talk to communities proactively, understanding what the societal impacts are of our infrastructure damage. During that project, we learned about water infrastructure damage. There was
Mm.
contamination within the water system in Paradise. I'll say we studied Paradise, but that fire impacted a broader
Oh yeah,
area
it was
and some of the
huge.
towns around it as well. Um, and so what we learned about was there was some thermal degradation of plastic pipes
Oh
um,
wow.
within the town limits. There was also depressurization and negative pressure at specific homes um, during the fire, and that sucked ash and soot into the system. This really shocked
Whoa.
me. This seemed like a heat transfer problem, and in coming
Yeah.
from a fire background, I was like, I can look into this. So that motivated an ongoing project. It's still going, funded by the Alfred P. Sloan Foundation to investigate this water infrastructure issue. And that in itself is a multidisciplinary project working with forest ecologists as well as social scientists and pipeline experts, as well as sensor experts to look at what are the exact mechanisms that this is happening and how can we perform laboratory experiments to isolate those mechanisms and understand how just thermal degradation of the pipes is influencing contamination or just negative pressure is influencing contamination? How does that vary with different pipe material? How does that vary with different elevations of the homes?
Mm.
How does that impact socially and economically a community? We're seeing it takes almost a year for the community to recover from that. So we've been kind of going and like just building off of ourselves with that project. And right now we are starting to model fire propagation through a community, at the same time modeling the water network and the demands on the water network, including firefighting, as well as when a home burns down, water is spewing from that home itself. So we're trying to aim
Oh
to
wow.
identify where the vulnerabilities are in the water network, and how home mitigation or property mitigation can lessen those demands because they lessen the intensity of the fire. So that kind of is like the water
Wow.
network side of things. Um, well, we're also working on what we worked on after the Marshall Fire is examining characteristics of homes that influenced survivability.
Mm.
And so something that was unique about the Marshall Fire is that it was really a true wildland urban interface community. You had the wildland and you had the homes, and they were very separate. And this was a suburban community with homes spaced very closely together, very similar actually to what we're seeing in Los Angeles. And so given those parameters, looking at what factors influenced survivability, and we did all sorts of machine learning, AI algorithms, deploying that on field data collected, and as well as data that we remotely collected.
Wow. As you were describing that, especially the last piece about home survivability and the factors that led to that, it reminded me of a story I heard about a statistician in World War II analyzing bombers returning back to England. Have you heard about this?
No.
So they thought, oh, we should add armor to these bombers where the most damage had occurred. Makes sense, right? But this statistician, Abram Wald, was like, well, let's actually add armor where there was no damage, because he realized that his data only came from bombers that survived. Those that were shot down weren't part of the sample.
Yes. Yes. Yeah. Yeah. So making sure your sample straddles both survived homes and destroyed homes is very, very helpful in that. And that's something that I'll probably be deploying next week to Los Angeles. And that's something that we're really curious about understanding more from that fire is really, looking at both destroyed homes and standing homes, and seeing what characteristics influenced that survivability or the cluster of survivable homes.
Thanks for listening to today's episode of Design Safe Radio. Be sure to like and subscribe on whatever platform you happen to be listening to this on. It really helps people find our show. Thanks to our amazing sponsors, the National Science Foundation and the NARI Network Coordination Office, which is award number 2129782. Big thank you to Marty LaChance, our guest booker and topic researcher extraordinaire, and Raquel Ruiz, who is our video and audio editor. I'm your host and NARI Facility Scheduling and Operations Coordinator, Dan Zahner. We'll see you in the next episode. Until then, stay resilient.